Yeah, what's the reference point that it gives? Does it say from the x-axis?
No, it just says determine the angle of the sum of v1 plus v2. But is it usually always from the
Positive x-axis is what it says right here beside it.
Okay.
Oh, on the far left.
So that's a little tricky because we might be tempted to either find this angle here or maybe that angle. But what they're asking for, they want you to start here at the positive x-axis and go like that.
To the resultant.
To the vector. So it's going to be 90 plus a little bit, whatever this ends up being right here. So what we want to do is we actually want to find this angle, which is the same thing as this angle up here. So since we've already got our triangle drawn, let's just find out what this angle is. We know that that angle is the same as this angle, so we just need to add it to 90 at that point, and that'll tell us this whole big angle. Does that make sense?
Kind of. The parallelogram kind of does, but so you did what now? So if you added the 90 to that angle, you'd get the...
Yeah, so because they want it, the reference point that they're using is the positive x-axis, which may or may not be the best reference point. I probably would have used the y-axis as reference point because it's closer. But whatever, they want it from the positive x-axis. So what we want to do is we want to find this angle that the positive x-axis is making with our vector. So that's this whole big angle here.
Which is 90 plus the short angle.
Right, because we know that from the x-axis to the y-axis is 90.
And how did you relate the small angle to your parallelogram, or how did you...
So we want to find this angle right here, the angle between the y-axis and our vector. And we know that that angle is going to be the same as this angle up here. You can kind of just visually see that, right? And the only reason that I made that connection, or that I even mentioned that, is because this is not an interior angle of our triangle, the way that we have it drawn right now. So in order to solve for this angle right here, we'd have to make a triangle like this. And then we could solve for this angle because now it's inside of a triangle. But since we already had our triangle drawn, we can just find the angle of this, or we can just find this angle right here, which is the same thing as this angle.
And can't you, because that makes a square, right? And a square is 360 degrees. And you can add the 90 and the 90, and then whatever's left over, 90 minus 360 divided by 2. That's just math.
Yeah, you could, yeah.
That would give you the angle.
You could do that.
Are they 45s?
So, well, we know this is 90. We know this is 90. We know this is definitely going to be something less than 45 because it looks pretty steep. And then this and this are going to be the same thing.
So what I did is I took the inverse tangent of the angle on the bottom right, and I found that angle.
This guy?
Yeah, I found that angle right there. Then I subtracted it from 90 because that's what's left in that quadrant.
Okay.
And then I added the other 90 to that.
Yeah.
And that gives you the right
answer. So you took inverse 10 of the angle just to the right of the 90 right there.
Yeah, so you could have found this interior angle of the triangle that we had drawn.
Or you took the tangent.
Oh, I took the inverse tangent because that gives you an angle. Inverse of sine, cosine, or tangent gives you an angle.
Oh, that's right. You go from angle to radians, angles. Okay.
So yeah, there's lots of different ways that we can do it. We could have solved for this angle and then recognized that whatever this number is the same as this number and then added that to 90. Or we can do it like Ben did it, solve for this angle, recognize that this plus this needs to equal 90.
It's 22.5, isn't it?
The angle? Yeah. The angle from the positive x-axis is 99.2, but they only wanted 2 significant digits, so it's 99. So it's 99. The angle I actually got is 80.8, and so what was left was 9.2.
So what was your total angle?
99 degrees.
Yeah, do you want to go through how to get it?
Yeah. So the inverse tan, the inverse tan is where it works when we're looking for an angle. The actual tan would be when we were looking for a side.
Good.
So side and angle, side angle.
Yep.
Okay, so the inverse tan of theta, which would be our
Yeah, so
unknown.
if this was our theta, and we were trying to find We were trying to find it using, we could use any trig function, any inverse trig function.
So it would be inverse tan of theta equals 6.59.
Yeah.
105, 1.05.
So we can say tangent of our mystery angle equals opposite, which is 6.59, over adjacent, which is 1.05.
And that's just what Ben did.
And then we want to get theta by itself, because that's what we're looking for. So in order to do that, we have to divide by tangent, which is the same thing as saying tangent to the power of -1, inverse tangent. Yeah, so that's...
Tan. But it is using inverse tan.
Mhm.
But it's just using the tan formula, the tan theta formula to find inverse tan of, to find an angle. Yeah, okay.
That makes sense
Yeah,
from
and then
here
that
to
gives us
there?
that angle, and all we need, we know it's a 90, so we subtract 90.
Good.
You get that. Then that gives that angle, and then you add to the 90, you get it. So you don't even really need to add it. Okay, anyways, yeah, I understand.
Yep, so that's just geometry. That's not even physics, but
So
you got to do the
99
geometry to
what?
get the physics.
99 degrees.
99.
Cool. Any questions there?
No, sir.
I was just trying to figure out how, because like I was saying, any square or rectangle has corners of 90 degrees, which equal 180 and 180, which is 360 degrees. So you have two 90s, that's 180. You have four other identical.
They're not identical, though. I mean, this one is identical to this
Yeah,
one.
that's right.
And this one's identical to this one, but it's not a four-way even
If it
split.
was a perfect square, it would be.
Exactly.
That would be fine.
Then we know that they'd both be
Rectangles
45s.
do not work that way.
So yeah, I mean, all of these would add up to 360, like you're saying, but we don't know, because we know that from here to here is 90, but we don't know how much of that 90 is here and how much of that is here.
Yeah, those are two.
And so that's where we have to start solving them independently.
All right, let's move on.